Hi, my name is Edward Morley. I conducted a scientific experiment in 1887 with Albert Michelson. In this experiment, we were questioning the properties and the existence of luminiferous ether. Aristotle came up with the idea of this substance, and the whole idea of it is just that it's something that fills up empty space and it can change the direction of light waves. Our whole main goal of the project and what we were trying to find, it was just that the whole idea of this ether thing didn't seem right to us. So we were trying to find a way to prove it wrong, or if we couldn't prove it wrong, we at least wanted to get a better understanding of how it worked. And so we did this by studying the motion of it relative to the Earth. Originally, it was thought to be that ether would change the direction of light. Either the light would go the same way as the ether, or it would go in the opposite direction. So our idea was that by measuring the speed of light in perpendicular directions, we could then determine the relative motion of matter through the stationary ether. Our research took place at K School of Applied Science in Cleveland, Ohio. Michelson had just taken a job there, and I was a chemistry professor at the nearby Western Reserve College. We began working on this project in the spring of 1887, and we published our conclusion in November of that year. There were also some other important scientists doing some research around our time. One that went hand in hand with ours was the research done by Hendrik Lorentz. His research was sort of contradictory to ours, but it also showed the same conclusion that we came up with, which was that ether is not real. And so basically, he did his after ours, and he just disproved any lingering ideas that people had about ether. And our research combined with Lorentz, they both contributed to Einstein's theory special of relativity. And this theory that Einstein came up with didn't use ether at all. So during the project, it was basically just me and Albert Michelson. He was my main partner. He had originally came up with the idea in 1881, but in 1887 we got together and we were determined to come up with a conclusion. He had designed this device called the interferometer, which would measure the velocity of the Earth through the ether by measuring how the light changes. It's pretty complicated, but this device was the key to proving that ether does not exist. My role in the project was basically just Michelson's partner. He came up with the basis for this project and research, but we collaborated our minds to come up with a way to set up this experiment using his interferometer, and then we sent a light source to a half silver glass plate, which splits the light into two beams. The beams each travel out to a mirror and then reflect back to the splitting point. They then recombined on the far side of the splitter in an eyepiece. And in the eyepiece, it produces a pattern of constructive and destructive interference based on the distance between the mirrors. So basically, Michelson came up with the idea for this. I just helped him work out all the kinks and come to a conclusion for his theory. The impact that our experiment had on the physics community is a pretty big breakthrough. Our experiment it's known to be one of the greatest failures in history. We had expected results based on the idea of ether, and whenever we didn't get these results, it was a real breakthrough because it was the first strong evidence that disproved the theory of ether. We not only confirmed the absence of ether, but we also found that the speed of light is constant in all directions. So this also goes to show that ether does not affect the way that light travels. In 1907, Michelson won an award for the Nobel Prize. I am sort of bummed that I didn't get the award, but I am honored to be a part of such important research. He received the award in 1907, and not only is it a big accomplishment just to receive this award, but it was also the first Nobel Prize in physics to be won by an American. So I'm just still to this day honored to be a part of such great research.